Hey everyone, thanks for putting up with this class being, I guess, canceled slash rescheduled slash recorded. I'm just afraid I wouldn't be able to host the live lecture Monday night. So here we go. We're going to get into chapter 23. I know we just finished, what did we just finish? Chapter, I don't know, 16 maybe? I think it was 16 that we just did. Yeah. We just did chapter 16, and now we're going to 23. And we have been just kind of following along sequentially throughout the book, but I'm jumping ahead to link because it's related to querying data sources. So it makes sense to put it in here. All right. This is a very, let's say, conceptual lecture tonight that there's not a lot of syntax. Well, maybe it's a little bit of both. But when we're done with this, when I'm done with the lecture, there's still going to be a lot up in the air because without seeing the code, it's not as straightforward as some other things. So we're going to get into LINQ. And LINQ is this language integrated query. So if you think about the SQL you're writing, especially in chapter 16, where you write out these long SQL commands, the SQL statements are just in a string. And it is specific to, in the case that you're working on, it's specific to a Microsoft SQL database, whether it's a database server or a local database. But what LINQ does provides a couple of great features. First of all, LINQ it's still a query language, but it's written in Visual Basic. What that means is if you screw something up, Visual Studio will tell you before you even compile your application. And also, let's pretend that you had a flat file database. You can then, if you're using LINQ, you can take that flat file, move it to a SQL database, and your queries remain the same. All right, you can query all sorts of different data sources. We are skipping over half of this chapter. We're skipping over the second half with these lambda expressions, so you can ignore step 9 here. All right, let's get into this. And this is, man, there's just a bunch of terminology here that we really don't need right now. So I'm just going to skim this really quickly. Yeah, let's just look at it. So when you write LINQ, you're writing a statement that looks sort of like SQL, but I put Yoda in here because I think it's a little backwards. Because you say, from this data source where these things are true, order by these things, select these fields. So in SQL, we put the select in the beginning, and with LINQ, the select actually goes at the very end. So we call I think of it as kind of, if Yoda were teaching you SQL, you'd end up with LINQ. So I mentioned it's integrated with Visual Basic, provides IntelliSense, giving you the code completion and such. The syntax is being checked. All right, so 3 stages. This is important. Step 1 is you get the data source, and the data source can be all sorts of things. You can select a bunch of data from a flat file, an XML file, which we do XML and flat files like the last week of this course because they're pretty easy. It can be just an array of data. It could be a list of things, which is like an array, only a list is open-ended. You can pull it from SQL Server, all sorts of things. And then you define what the query is. So that's when you write your, from this data source where this is true, select these things. And then you actually execute the query. So an execution is deferred if you don't need to do any type of calculations right away. So if on deferred execution, the data source is actually queried once you need it, like in a for each statement or something. But immediate execution occurs if you have, some sort of computation in your query. Like if you say select sum of invoices.total, that's an immediate execution. All right, so here's some examples. Time to show you some examples. Hopefully this will make sense then. So we have an array of integers that we just fill up from 0 to 5 here. Upper bound is 5. And then we have our link statement. So this, again, looks a lot like SQL. So we're saying from number in numbers. So numbers is our data source, which is defined right here. When the number mod 2 is equal to 0, that's our where statement. So we're only taking things that are divisible by 2. Order by the number in descending order, we're selecting the number. And we're going to put this back into a list. This number list is just like any other list. Okay? And then we say, we have our loop here for each number in number list. We're just going to build this display. So what it works out to be is this. Okay, so we have even numbers sorted in descending order. You probably would not do this in an actual application, but it's the simplest version of using LINQ. So let's break this down. We're going to start with the from clause. So if we had an array of sales totals that are all decimal values, and we wanted to just pull all those out of there, you'd say from sales and sales totals, that's what you're going to put into sales list. And then you're going to say for each sales in sales list, in this case, we're just going to add them all together. This from sales in sales total, you generally use that same word in your for each statement as well. And well, I don't have an example of this one. This just added it all together. And I think the book is, we're on, if you're looking in the book, 740, 741. The book makes a great point here. It says, why would you use a query expression for something like this? Instead of just looping through instead of just saying, for each sale in sales totals, right? Instead of just looping through this array. So why would you do this? You wouldn't. So I think it's great that the book points out that sometimes we show examples just to show you this is how it's done, but this is not necessarily the best way to do it. It's get a little more complicated because remember, when you're querying with LINQ, you're querying all sorts of data sources. And in this case, we're going to have a list of invoices. So again, a list is an open-ended array, think of it that way, that can hold any type of data. In this case, we're going to hold an invoice, and you can see what the invoice class looks like. It has a bunch of properties in it. And we're going to be using the invoice class in chapter 23. And the invoice DB class has a method called getInvoices, which, as you imagine, opens up some sort of database, and it returns the list of invoices. And that's now stored in invoice list. So we can say from invoice in invoice list, put that into this invoices variable. When we loop through those, for each invoice in invoices, sum plus equals invoice.invoice total. So we're getting to the point, okay, now we get this idea that we can query other things, right? We're querying a list of invoices here, but this is still kind of a lame example of what this can do because we're not really doing anything other than just looping through the list. But we can actually query our data source. That's what LINQ is doing. So if we have a list of invoices, we can say, I'm sorry, in this case, we have a list of sales. We only want to know sales that are greater than 2,000. So instead of writing a for each statement and looping through all of the sales and then saying, if the sales total, if sales is not greater than 2,000, then continue. Here we're querying the data directly. So our sales list is going to say from sales and sales total, where sales is greater than 2,000. Again, here we're just, for an example, we're just building a string that we're going to use messagebox.show to show it any sales over 2,000. And we are just showing that to the screen. So this is what it looks like. Sales over 2,000. So there's other sales, presumably, in this this sales list. but we're only showing the ones that are over 2,000. Going back to our invoice example, we can query the invoice list. So we're saying from invoice in invoice list, where the invoice.invoice total is greater than 150. So this is giving us back a list of invoices that the total is over 150, and you can see the display here. Order by, fortunately, a lot of this stuff works a lot like SQL, so I'm kind of flipping through this pretty quickly, but the nice thing about this, again, is that your syntax is being validated right within Visual Studio. So order by can either be ascending or descending. If you don't specify the order by, ascending is the default. So we're going back to our sales example, and where sales are greater than 2,000, order by sales, again, implied here is ascending. So you can see that here's our sales that are over $2,000 in ascending order. Here we're looking at invoices again, where the invoice total is greater than 150, and we're ordering it by invoice.customer ID. And again, because it does not say ascending or descending, ascending is assumed. And then after we order it by customer ID, we want to order it by the invoice total descending. And we build a string to show in the message box. And here's what that looks like. So you can see the customer ID 10, 20, 20. This is in ascending order. And within the 20s here, invoice amount is in descending order. So there's only two customers that repeat. We're going to show the greater invoice first. And finally, after all that, we choose what we're going to select. And if you select anything other than everything, it's called a projection. So if you're selecting one field, it's going to come back as that data type. But if you're selecting two or more fields, what you get is like an object of this anonymous type that's just going to encapsulate the different fields as their own type. All right, that'll make more sense when we go through the example. So here we have a sorted list. We have salespeople, right? Employee sales. Yep, salespeople, and looks like how much they sold. So from sales in employee sales, that's the data source. The select condition where sales.value is greater than 2,000. So at this point we throw out Anderson, right? Because we're only looking at the ones that are greater than 2,000. Order by sales.value descending. So it's going to be Thompson, Mendez, then Wilkerson. Select sales.key. So we're only taking back the key, which is remember this is key value. And here we are. So because we're only selecting one thing, where's my cursor? Here we go. We're only selecting one thing, the key, which is a string. When I go to build this, again, as an example, we're just showing this on screen. When I go to build this for each employee in employee list, employee is a string. So I'm just going to add that here. For some reason, they put the name and then a bunch of tabs and then a new line. So here's employees. Oh, probably just so you can see the whole message box title. I don't know. So we're only pulling out one field. And so when I loop through this, that thing that I'm looking at has the same value as that field. I can select everything. Here I'm going back to that invoices class. I'm selecting the entire invoice. And do we have an example of this? No. So when I do that, I have the type that comes back is of type invoice. Here I'm selecting invoice.customer ID, invoice.invoice total. This is where it's going to take this because it's not an invoice. Because an invoice, if you remember, if I come back, where's my invoice? An invoice has an invoice ID, customer ID, invoice date, all this stuff, right? But if I'm only selecting invoice.customer ID, invoice.invoice total, it's not an invoice because it only has these two fields. So what type of object is this? This is an anonymous type. You can't reference it again. Doesn't have any methods to it, but it's going to hold customer ID, which is an integer, and invoice total, which is a decimal value. All right, and finally, we can join things together. So if we had a customer class, for example, like what might be on chapter 23.1, and we get the list of invoices and we get the list of customers, remember that invoice has a customer ID to it, which we can join to the customer ID in the customer class. So from invoice and invoices, or from invoice in invoice list, you can join customer and customer list on invoice.customer ID, and here you write out the word equals customer.customer ID. We're selecting it where the invoice total is greater than 150, order by customer.name. You see the order by there. You see the select again, customer.name and invoice.invoice total is going to be put into an anonymous type. And then when we loop through it, you see here's the customer name in ascending order and the invoices for that customer in descending order. So Sarah Chamberlain was customer 20. She has two invoices, one for $239, one for $172.88. You can also do this implicit inner join. I don't know if we talked about this when we were playing with SQL. So you can just, so we're saying from invoice and invoice list, comma, customer and customer list. So we're just going to list out our, what we're pulling from. And then when we do this, where invoice.customer ID equals customer.customer ID, this is that implicit inner join. I don't know, it's personal preference. If you're doing an inner join all the time, then this is easier. But if you're doing any other types of joins, I like to write it out. All right, so 23.1, and I'm just going to go right into 23.1. So 23.1, when you start out, you're going to pull from the invoices, and you're going to get the invoice ID, date, and total. We're going to put it in this list. And eventually, it's going to look like this. So, all right, I told you I'm going to just jump right into it. All right, and open the project. All right, make sure you open the 23.1 that I give you in Blackboard because I've made some changes to the Invoice DB and Customer DB applications already. So it wants us to look at this. No, we're not looking at it yet. Okay, so we have our form, and it wants us to add a list view control. So if you have common controls open, we have list view right here. If you don't have list view, you'd have to go to all Windows forms and find list view. Throw it on there, make it a little bit bigger. And then it wants us to set the properties on this. Set the view property to details. All right, and then use the Smart Tag menu to edit columns. And we are adding a column for, so they look like 2310. All right, 2310, sorry, the last three in 2310, or not the first one. So we have invoice ID. We're going to add a column for invoice date. And we're going to add a column for invoice total. And you can see behind here, the columns aren't wide enough. So I'm going to select all three columns and change the width to 100. Yeah, that'll fit. Okay. There we go. So now open up Invoice and Invoice DB classes. We're just kind of taking a peek at these. Here's Invoice. Has a lot of public properties. That's it. Invoice DB has get invoices, which reads this file here and creates a bunch of invoices. The important thing about get invoices is it returns a list of invoices. Okay, going back to my form here. It says add an event handler for the load event of the form. So I'm going to choose form events. I'm going to choose load. And use the get invoices method to get the list of invoices. Store this list in a variable. So dim invoice list equals sorry, let me make this a little bit bigger so you can see it. There we go. All right. Invoice list equals invoicedb.getInvoices. Remember, invoicedb, get invoices, returns a list of invoices, so I'm going to save that in invoice list. Then I'm going to define a query expression that returns all the invoices from the invoice list. So I'm going to say from invoice in invoice list. Okay? And sorts them by invoice total, in descending order. Notice, let's even do this. Okay, order by invoice dot. Here I have auto completion. I have IntelliSense running. Order by invoice total. Descending. Yep, that's what I want. Whereas if I had a select statement like we were doing in chapter 16, and I said, select star from invoices where order by, like, none of this is being auto-completed. I could say order by total descending. Well, total is not the right field, but because my select statement's just in a string, this would be a new string. Because it's just in a string, Visual Studio doesn't know, what this table looks like or anything. But using link, it's giving me, if I said order by invoice, I can't even put in the word total. If I just put in the word total, it flips it over to invoice total for me. Okay, so that's one of the advantages of link. Include a select clause. This selects the entire invoices, so I'm going to select invoice. It's going to give me the entire thing. And then I'm going to say for each invoice in invoices, this is step 7. Load the results into the list view control. So list views is something that we haven't worked with yet. The first thing I want to do is take my list view. I'm going to rename it to LST invoices. I come back to my code. So for each of these invoices, I'm going to do LST invoices dot items dot add. And what I'm going to add to it, you notice the first column is invoice ID. So I'm going to add to it invoice dot invoice ID to string. And hit F5. Let's run this. There we go. Invoice ID 59, blah, blah, blah. And that looks good. Now, if I do, and how about don't do this? I just want to show you that this does not work. So let's say I want to add the next item on to this, which is invoice dot invoice date. Now I hit F5 again. Oh, it put it in the same column. We don't want that. We want invoice, then we want it to move over. So we don't want that. What we need to do is up here, I'm going to say dim row as integer equals 0. This is my row counter. This is where I'm currently sitting right now. All right, so to add additional columns, we're going to do LST invoices dot items, and instead of adding, we're going to actually look at this particular row that we're on. We have this sub items property, and then we're going to add, in this case, I'm going to add again the date. So this is not something that has anything to do with link. This is just happens to do with list views. So it's LST invoices dot items, the row that we're on. To the sub items property, we're going to add invoice date as a string. What I need to do, don't forget, at the end of your loop, you have to do row plus equals 1 to make sure you move that row counter. All right, there we go. So we have invoice ID, invoice date. Invoice date right now is a little too big, and all we want to show is the date, not date time. So if you remember, we have to short date string. We have that method available to us. And then we want, in the third column, we want the invoice total. And I'm going to take that, I'm going to put it in format currency. Hit F5 here. There we go. So we have invoice ID, date, total, and we're ordering by invoice total descending. Yep, that looks right. All right, so that was step 8. Step 9, modify the select clause so it only returns the fields needed. So right now, when we select invoice, we are getting an invoice object back. Once I change this, that I only want to select invoice dot invoice ID, invoice dot invoice date, and let's pretend that's all I did, right? I only selected invoice dot invoice ID and invoice dot invoice date. Visual Studio is telling me, hey, you're trying to use invoice total, but we don't know what that is. So, I wonder how IntelliSense is on this. Nope, we don't want to do those. Okay, so we need to make sure we select invoice dot invoice total as well. Now everyone's happy. Let's just clean this up a little bit. Wish I kind of like that blank line there. Okay. So nothing really changed. Application still works as planned. So step 10, take a look at customers. A customer has a customer ID and a name. Remember that an invoice has a customer ID as well. And then customer DB is doing the same thing. It returns, get customers returns a list of customers. So, all right, step 11, add another column at the beginning of the list view. I'll go back here, edit columns. I'm going to add a column. This column is going to be named customer. Customers are big, like 150, maybe 200. All right, 200 looks good. And set the display index, right? So if you look at the display index right now, header 1, which is invoice ID, has a display index of 0, 1, 2, 3. I'm going to set the display index for customer to 0. And then I'll rearrange the other ones. Now invoice ID is display index 1. All right, and that's going to put customer first. Okay, add a statement to the load event. So basically we need to load our customers as well. So I'm going to have customer list. And I just went kind of quick there. When you're on the line for invoice list equals invoice DB get invoices, hit Control D, and it'll make a copy of that line. Instead of invoice list, I want customer list. I'm going to pull it from the customer DB, and I'm going to run get customers. Okay, now modify the query expression. So it joins the data in the customer list with the data in the invoice list. So what I'm going to do is from invoice in invoice list, customer in customer list, where invoice dot customer ID equals customer dot customer ID. This is that implicit join. It sorts the result by invoice total within the customer name. So we're going to order by customer dot name, comma, invoice dot total descending. And the only fields that are needed by the form are returned by the query. So we are going to need customer dot name as well. All right, so now if I run this right now, I gotta say, I don't know why customer was not pre-filled. Okay. Yep. So sorry about that. Make sure you go back to your columns. This is the collection of column headers. This is the display index. They don't always line up. They don't line up at all. So make sure you take column 4 and move it to the top here. So when you run your application at this point, it should be shifted off one, right? Your customer should be filled in with the invoice ID. The invoice ID should be filled in with the date, and the date should be filled in with the total. If you have this, that's good. Okay, so we need to fix that. I'm going to duplicate this line and comment out this one, because the first thing I need to do is I'm going to add to this invoice.name. And remember, invoice.name is the customer's name. And then I'm going to duplicate this sub-item add. And what I'm going to do is I'm adding the invoice ID. So we're going to add the customer name, and then to the sub-items, we're adding the invoice ID, and then the date, and then the amount. So it looks like this. So there we joined it together. If you have this, that's good. The book says don't worry about not repeating the customer name, but I want to make that functionality work, because it's something that I think adds a little bit of cleanliness to the code, and it's something that I don't think we've really talked about before, not repeating something. So the way I'm going to do this is I'm going to say dim current customer as string. So I have, right now I'm saying this is my current customer is nothing. And then here I'm going to say if current customer is not invoice.name. So if the current customer is not the name on the current invoice, then I want to show the current customer's name. Otherwise, I want nothing. So if I run this right now, it should have no change whatsoever, because current customer is always nothing. We never overwrote that. So to change that, we're just going to say as soon as we see that the current customer is not the customer's name on the invoice that we're working with, we're going to set that to be true. And really, you could put that anywhere. I put it here because it's most efficient. We don't need to run it every time, but you can put that, you can even put that down here, whatever. I like it in here. So let's imagine this. Current customer is nothing. We look at the first invoice. Is nothing equal to the customer's name? It's not equal to the customer's name. So we're going to add the customer's name to the items, and then set the customer's name to current customer, and then add all this other stuff, increment our row. Come back through again. Let's pretend it's the same customer. Is the current customer not equal to the same name? Well, that's not true. So we're going to add nothing instead. And when we run it this time, you can see Sarah Chamberlain, her name only appears one time. Here, these other two are blanks. So just make sure that your box and everything is nice and tidy. A few of you are kind of submitting forms that are huge, a lot of empty space. So let's just tidy it up a little bit like that. That looks better. I'm going to take my form. I always like to make sure that we're opening in the center. And then this is called Customer Invoice Application. Now when we run it, there we go. I'm going to call this a finished product. So there's your slides for half of chapter 23. I skipped over lambda functions and lambda expressions. We're not worrying about those, but there's also how to complete 23.1.